brief review. I'm not going to go into any of this, but on Friday we started talking, for those of you that weren't here, about even and odd functions. Okay, so we talked about even and odd functions. Even, it's either symmetric about the y-axis or f of x equals f of negative x. Those were the two ways to tell, and that's in the notes. If it's an odd function, it's either symmetric about the origin or f of negative x equals negative f of x. We had that algebraic option also. And then, of course, the third option is neither. So in class, we spent a little bit of time looking at graphs, saying, okay, hey, this is symmetric about the y-axis, so it's even, or this one is symmetric about the origin, so it's odd. And then the trickier part is we looked at the equations. And so on these, we would find f of negative x. And that means every time you see x, you replace it with negative x. If f of x and f of negative x were equal, that was even. The other thing we would find is negative f of x. That's just multiplying everything by a negative. And if that equaled f of negative x, it was odd. And if both tests fail, it's neither. Okay, so that's all in the notes from last week. If you haven't had a chance, make sure you go back and look at that, get your notes caught up. Now, today, we are talking about transformations. In fact, notice what's up on the TV. Back in topic 1, we had these green formula papers, yes? Or in topic 2, we had these blue ones that's at the top of there. So you have the chart 2 different places. I always have more copies of those if you need one. But we're going back to those. The difference is now that we are just focusing on cubic and quartic parent functions. Cubic means something raised to the third. Quartic means something raised to the fourth. Okay? So we'll talk about the graphs here in a little bit. But one of the things we need to be able to do, what we've been doing since chapter 1, is being able to tear this apart and describe it. Okay? What are the various transformations that are happening? So going back to your list of transformations, okay, that hopefully are becoming pretty familiar to you at this point, and figuring out what all the pieces are. So as we look at A, g of x equals 3x to the fourth minus 18. What kind of transformations do you see? What's the 3 going to do? Or what's the 18 going to do? I think they forgot we did this. Or they're just all being quiet on Monday.
Sure.
What do we know? X to the fourth is the basic here, but what's that minus 18 doing? Minus 18 is where? Moving down 18. Okay, that's like right here where it's the minus value afterwards. It's not in with the x. It's outside the parentheses or outside away from the x. So that minus 18 is going to be down 18. What about that 3? What happens when a number is multiplied out front? The number is multiplied out front. It's either vertical stretch or compression. Which one is it? Stretch. It's a number greater than 1. So that 3 is going to be a vertical stretch. Okay. Those are the only two things going on here. The other piece that I asked you to do here, and you'll see them doing this in Savas, and then when you get your review worksheet tomorrow, is what is the original function that this is being done to? Okay. In this case, the function this is being done to is x to the fourth. Okay, that's our parent function. So that's the only piece I kind of asked you to add in. In the past, you haven't necessarily had to do that, but the fact that it's the graph of y equals x to the fourth is vertically stretched by a factor of 3 and translated down 18. Okay, so looking for some type of description like that. I'm going to write it out. I would encourage you to do the same. I'm going to say the graph of y equals x to the fourth is vertically stretched by a factor of 3 and translated down 18 units. Okay? So those are some of the pieces, I'm looking for there. I do want you stating y equals x to the fourth. So tell me what graph we're talking about. The fact that it's vertically stretched, factor of 3, and the fact that it's translated, shifted, moved, something about down 18. Okay? Obviously, your wording can be yours, but those are some of the key pieces of information you need in there. Okay? Sound familiar? It's very much like what we've already done this year, isn't it? I told you guys this keeps coming back like every chapter, and it does for quite a while. So, okay, what about B? H of x equals 5 times x minus 2 to the power of 3 plus 4. What do you think? What do you see? Five is what? No. Or are you looking at this one? No. Okay. 5 out front is?
Oh, never mind. I'll get the wrong one.
Yeah. Multiplied out front. So since 5 is bigger than 1, that's going to be a vertical stretch. What about that minus 2, folks? Minus 2 is going to take me which way? I need you guys to tell me some of this. I don't want to tell you all. Gotta get some answers from you guys. Minus 2 in the parenthesis?
To the right, too.
Yeah, it's going to take us right to. What about that plus 4 at the end? Plus 4 outside the parenthesis is going to take us up 4. Okay. So remember, in the parentheses, left to right, opposite the sign. So that is going to be right 2. The number added or subtracted at the end is up or down. And that's just the direction of the sign. What graph is this being done to? My parent function here is x to the third this time. Okay, so again, make sure you state that. So the graph of y equals x to the third, or you could say the function, is vertically stretched by a factor of 5 and translated right 2 and up 4 units. Okay, key pieces. State that it's y equals x cubed. It's a vertical stretch, not just a stretch, but a vertical stretch. What factor is it? 5. The fact that it goes right 2 up 4. Do use a verb there. I like translated, but shifted, moved. Don't just tell me it goes right 2 up 4. Use some kind of verb. Okay, so C. I really should have probably changed these up some. They're kind of repetitive, but that's all right. What do you know about C? F of x equals 2x cubed minus 5. The 2 again, it's a number bigger than 1 again, so vertical stretch. The 5, it's not in the parentheses, so it's just going to go down 5. And this is being done to the graph, x to the third. So the graph or function, y equals x to the third, is vertically stretched by a factor of 2 and translated down 5 units. Okay, make sure you have all the important pieces. Okay, make sure you have all the important pieces. Okay. In that scenario, they gave us the equation, and they asked us to describe what's happening to the graph. Okay. In the bottom half of this page, they're going to give us graphs, and we have to write the equation for it. Now, we're pretty much going to use these type of pieces right here that we know when the graph does certain things, that's how we put it in the equation. But before we go too far, you need to know these 2 basic graphs, okay? These are the 2 basic graphs that they are using. It's either going to be an cubic x to the third or a quartic x to the fourth. If it's a cubic x to the third, this is one you should start committing to memory, okay? Kind of like I say x squared and I expect you guys to know it's a parabola, right? So x to the third, I'd like you guys to get to the point that you know that it's this curve. The basic x to the third graph, it's good to know that it goes through 0, 0, that's the basic one. And then the first set of points are over 1, up 1, or right 1, up 1, and left 1, down 1. So that helps you a little bit with the shape of the graph, okay? The next set of points would be over 2 and up and down 8. You just can't see those on this graph. So that is your cubic, or y equals x cubed. The other one we're going to look at is the quartic graph, or the x to the fourth graph. It looks a lot like a parabola, but it's not. It is slightly different. I will say it does still start at 0, 0. The first set of points are indeed over 1, up 1, but if you remember from a parabola, it was over 2, up 4 for the next set, whereas this is actually over 2, up 16 is the next set. So just for reference, so you can kind of see. Yes. So right there, if you look at the graph, that blue one is the parabola, is the x squared. And the red one is the quartic graph x to the fourth. And in fact, if we zoom in a little bit, you can see how the blue one kind of curves up more, whereas the red one is flatter at the bottom, and that's what you see going on with the quartic curve. It's flatter at the bottom, but it goes up quicker. It goes up steeper. Okay? So be familiar with those 2 graphs. Know that it's one or the other graph that we're looking at today. Okay? Now, with the knowledge of those graphs, what we're going to do is we're going to take a graph and we're going to try and write an equation for it. Okay? So determine the equation of each graph as it relates to its parent cubic function or quartic function. So as I look at A, okay, before I write this equation, I want to go through and identify, what do you know? Is this going to be an x to the third graph or an x to the fourth graph? Which shape is this?
Is it still x to the third?
It is. Yep, it is going to be an x to the third graph, and I'm just kind of making myself a list of notes here off to the side. It is going to be an x to the third graph. It has that shape. Yes, it's moved. It's no longer centered. Yes, it's flipped. It goes the other direction, but it's still that same shape. Now, what has made it different? What are those pieces that are going on? If it normally goes through 0, 0, where does it go through now? Yeah. Now my centering point is at 2, 4. So somewhere along the line, it had to move right 2 and up 4. So I'm going to make myself a note that it goes right 2, up 4. What else happened along the way? Does it still look the same? What did it do? Think in terms of the transformation you can't see on the screen anymore. What did it do that would make it, instead of going up, go down basically? We're going to go X. Technically, we could talk either way. We could talk reflected across the X or the Y, but generally what's easier for us to use is, because you could look at it either way, it's going to be easier to do reflected. Well, yeah, reflected across the X is what we usually say. Okay. Again, we could put it either way, but so there is a reflection. Now, the other thing I encourage you to think about is there any vertical stretch or compression? If there's a vertical stretch or compression, your basic initial points are going to change. In this case, if this is my centering points, notice I have one point that's over 1, down 1, and over 1, up 1. Is that similar to what the original graph was that I showed earlier? Yeah, those first set of points went over 1 and then up or down 1. Okay, so there is no vertical stretch or compression, but that's always something good to check for. So let's write an equation. I am going to start with f of x equals. I'm not against you starting with y equals. I will say Savas will probably already have it set up for you, so you won't have to put that part. Okay, let's start with how do we express right 2? In order to go right 2, we're going to put that, not right 2. Right 2 is in the parentheses, but what? Opposite sign. So we're going to have in the parentheses x minus 2. Okay? Because that represents right 2. Now, which function was this? Was this cubic or quartic? This is supposed to be cubic, right? So where's my power of 3 go? My power of 3 goes outside the parentheses. Okay. We have an up 4. Where does my up 4 go? Up 4 is a plus 4, and it's just at the end. And then, what's the piece we're overlooking? Or not overlooking, but just haven't gotten to yet? It reflected. How do we show a reflection? We're going to put a negative. Okay? So right there is the equation I'm looking for. Negative of x minus 2 cubed plus 4. Okay? Questions on that? Use the green papers to be helpful, right? Okay, let's try B. What shape is B? X to the third or x to the fourth, class? X to the fourth. Okay. You could try and tell me it's x squared, but here's the deal. The directions only give us the option of quartic or cubic. So those are your options. So it's x to the fourth. Does it reflect? No, it's still right side up. What about my vertex is normally at 0, 0, but where is it here? It moved. Yeah. Left 1, down 3, so -1, -3. So I'm going to list that as left 1, down 3. It doesn't reflect. We've got our left and right, up and down. The other thing I ask you to always consider, is there vertical stretch or compression? And here's what I would look at. From the vertex, is the first set of points over 1, up 1 in both cases? And they are. So that would be different if there was any type of vertical stretch or shrink. Okay? So, f of x equals, what goes in my parenthesis? Okay. Left 1 is a +1 in the parenthesis. What power are we using outside of the parenthesis? X to the 4th. Down 3 is shown as -3 outside. And do I need a negative out front? No, because there's no reflection. Got the basics? So that's what we're doing here. Okay. Let's see if they can trick you up, because they're going to try. What about C? Okay. It's x to the 4th, yes, it's that U shape. Of course, it is an upside down U, which means it is a reflected x to the 4th shape, yes. Normally my vertex is at 0, 0, but in this case my vertex is at, what point is that? Because as I said, they're going to try and trick you. 1, 5. They have the 1 labeled, yes. They count every 2, but they have the 1 labeled. And then along the left, count up 1, 2, 3, 4. So this is indeed 5. So this is a right 1, up 5. What about those first set of points? Are they over 1, down 1? Or is there a vertical stretch or compression of some sort? Now, can you see the first set of points? You can see where they cross, yes? Okay. What are they? What do you think?
It's over 1.
Oh wait, is it because the numbers are different?
So count here, if we're going over 2 boxes, what is that listed as?
1.
That is over 1. If you go down 1, that is actually 1, isn't it? Now, as I said, they're trying to trick you, aren't they?
Fake.
Okay, so pay attention to how they label their axes. Okay, so f of x equals, are you getting the hang of writing these? In parentheses, we're going to go right 1, which is x minus 1. My power is x to the 4th. That's always going to go outside the parentheses if you have a left or a right. Up 5 is plus 5 at the end. And I need a negative for a reflection. If you had to do any type of vertical stretch or compression, I don't remember if you do in the homework or not. If you do, that number would go right out front with the negative here. Okay? Okay, D. What shape is D? This is an x to the 3rd. What do we know about this x to the 3rd graph? Okay, it is reflected. It's supposed to be increasing, going up. but instead it's decreasing, going down, so it is reflective. Where did it move? If it started at 0, 0, note where that center point is, and it moved. Yeah. Left 3, down 1. Feeling any type of stretch or compression? And it looks like that first set of points are over 1 and then up or down 1, doesn't it? Okay, write yourself an equation. F of x equals, and you can write this in whatever order you want in, but I'm just trying to give you kind of a process. Left 3, I'm going to do x plus 3 raised to the power of 3. Down 1 is minus 1, and a reflect means there is a negative out front. Okay. One more. What do we know about E? What graph is this? This is x to the 4th. It really looks like x squared, doesn't it, the way they drew it? But, again, they told us in the directions, cubic or quartic. What do we know about this graph? Okay. That vertex went from 0, 0 to 2, 6, so that means it had to move right 2 and up 6. Any reflection? No, it's still right side up, so no reflection. Any stretch or compression? They labeled a point for us, right? And that point they labeled, it goes from 2, 6 to 1, 7. So those just both changed by 1? They did. Did they try and trick us again? Yeah, because they labeled the x by 1s and the y by 2s. So just beware when they do silly stuff like that. Okay. F of x equals right 2. It's going to be x minus 2 raised to the power of 4, because it's a quartic. Up 6 is a plus 6. No reflection, no stretch or compression. So there you go. Okay? Okay, guys. Homework is lesson 3.7. Okay? You have time. Use your time. 3.7 went pretty quickly for some people this morning. So, I think it's 12 questions when I looked, but some of it's some multiple choice and stuff that goes pretty quickly. What I will also say, though, you have time. Not a whole lot of people turned in 3.6. So, you might double check and see if you turned in 3.6. Okay? If you didn't already see it on the board, or notice, this is the last page in your notes packet, right? Last page of your notes packet means now we are headed to a test. So I'll have review packets to hand out tomorrow, and the rest of the week working on those. Test on Friday is the plan. Okay?